In this video, we're going to take a look at some basic deployments in Kubernetes and how cluster info can help you demonstrate these concepts in your workshops and presentation. So let's go ahead and start off by applying a deployment to the cluster. As you can see, cluster info allows you to see the internal process of the pods and the containers being created. You can also navigate across different deployments and see their status. And you could also look at these pods from the perspective of the namespace, from the perspective of which nodes had which pods allocated. But in this demo, we're going to focus on just deployments and what happens. So let's go ahead and make a change to that deployment and watch how Kubernetes creates a new replica set and a new set of pods. Okay, so we're going to change the color label in the deployment. As the pods are being created, the previous pods are being deleted in a systematic manner. That means they're not being deleted all at once. This type of deployment is called a rolling update, and we're going to take a look at the details of that type of update a little bit later on. But you can see that's a property of the deployment itself that determines how new pods are created. Okay, so now while the previous pods are gone, the previous replicate set remains, and this allows the user to roll back to that replica set if they so choose. So if you could look at the pod template of the previous replica set, you can see that its definition clearly has the previous color label, while the current replica set has the definition of the current deployment. Okay, so let's go ahead and make another change and see how that process works again. Now, as you can see, the process works again, and again it maintains the previous replica set so that you could roll it back. Okay, so you can see the command that was used to apply that set, the image that was used, and most of the time you're gonna be applying these on the images rather than the color, but the color is much easier to see and demonstrate. All right, so let's go ahead and undo this deployment, and let's go ahead and use the built-in functionality to roll it back to the previous replica set, in this case revision 2 with the yellow color label. Now notice what happened. Kubernetes does roll it back to the previous revision, but it uses the template of the previous revision, in this case color yellow. However, it does create a brand new replica set, and removing the number 2 revision that it had in its system, because just like pods, replica sets are immutable. Okay, so it uses that template in order to create a new one. Okay, so let's go ahead and create yet another change to this deployment. Okay, now we're going to change the label just to see it. And again, you can see as things are replicated, you can see what's going on internally. And then with each one of these, you could also look at the labels of each of these different replica sets to see how they've changed along the way. Like I said, in the demo, you'll see those changes reflected in the color, but in actuality you'll see those changes most often reflected in the image name, like in a build process. New images or new image versions are updated to the deployment. Now let's go ahead and see what happens when you specify an invalid image in a deployment. Notice that the new replica set is stuck. However, because of rolling update, the deployment did not delete all of the previous pods, right? Because the way the system works by default is that with a rolling update, it only deletes a few of them. In fact, it only makes 25% unavailable at any given time by default. Of course, you can change that so that it allows the new pods to be created, validated before they're all deleted. So the advantage of using this type of deployment strategy is that you're assured that your old version doesn't go down while your new version is deployed, even if it's a bad version or something wrong with the image or some other reason why the new pods can't be created. So that's a very nice feature. All right, so let's go ahead and roll it back to the previous good version. Again, it's going to take revision number 5, which was pink, make it into revision number 7, still keeping the history. Now, notice that at this point we have 5 different revisions. Now it's very easy to undo the rollout and go back to the previous revision. However, what's the point of having all of these other revisions if you can't go back? Well, of course, the answer is you can go back by simply specifying the revision number in your undo rollout command. So if I were to specify revision number 1, I can go back all the way to revision number 1, use that template, revision number 1 is gone, and now revision number 8 is now the template for the current replica set. So up to now we've looked at the rolling update. You can see how individual pods are created, and individually, one by one, the old ones are deleted, and you have control over that with the max surge and max availability. But what if that's not practical? What if the change you're making is a breaking change and you can't have both the old and the new deployments live at the same time? So Kubernetes allows you to have a different type of deployment strategy known as a recreate. And with the recreate strategy, it ensures that all of your previous pods are deleted before the new pods are created. Notice that it's going to wait until every single pod has been completely terminated and deleted before any of the new pods are created. Now, obviously, this strategy has some risks that if the new deployment is invalid for any reason, this strategy isn't going to work, and now you're going to be in a broken state. But if you do have a breaking change, this is certainly one option. Now, as you can see at this point, we've got quite a few revisions, and chances are, if you're doing this in a build process, you're really not going to need that many revisions. So you can control how many revisions you have in history by simply setting the revision history to a much lower number, and we're going to set it to 2. And as you can see, once the new deployment happens and I set it back to rolling update, that only 2 of the revisions will remain. So you don't have that long overhead of keeping previous templates around when you don't need them. So if we look at the summary of the entire process, we can see we applied the deployments, we made some changes which caused new replica sets to be created, still all within the same deployment. We can undo that deployment to the previous state. We can specify invalid names and then undo it again, and then undo it back to a specific revision. We can change the deployment strategy by setting the recreate, and of course if it's not specified, rolling update is the default, and then we can change it back to rolling update, and also have limit the number of revisions that we keep around. So that's a quick demo of how you can perform basic deployments within Kubernetes and use cluster info to show you what those deployments look like. Thank you.